All right, so today we start solving inequalities. Okay? An inequality is a statement comparing two expressions. And you have some examples. So for example, you could have something that says like y is greater than 2. Okay? Or 2x is less than or equal to 4. So there are certain numbers that would make that equation true. Those expressions. Obviously, to plug into y, you have to have any number bigger than 2 for that to be correct, right? Excuse me. If I put in a 1 for y, would that be correct? Is 1 greater than 2? No. So any number bigger than 2 would work. Same thing here. You could plug in a 2 for x because, right, 2 times 2 is 4. And that's what less than or equal to means, right? It can equal 4 or it has to be smaller than 4. Okay? So when I was talking about solutions, a solution is any number, and that is the number sign, not the hashtag that your generation knows by, that makes the inequality statement true. Did everyone get the definition for inequality? Okay, that way I can at least cut that off. There you go. So now when we solving an inequality is similar to solving an equation. Okay. You can't list all of the solutions so we show them by graphing them on a number line. And we're going to give you some examples here in just a second. Hold on. It's going to disappear for a second. It'll come back. Hold on. There you go. So again, what are the 4 types of inequalities? Well, when it's got a line underneath, okay, this means greater or equal to. Okay, when basically think of the point or the mouth, they used to call it the alligator mouth, opens up to the left, it's greater than. When it's the other way, this is less. Less than or equal to. Now when it's just a sign, this means just less than. There's no equal to. Actually, I got it backwards. Hold on. This is less than. Let's just do this. This is less than. This is greater than. Because we always go left to right. Now, when you're showing this on a number line, anything that's greater than or equal to, you're going to use a closed circle. We call it a closed circle, meaning when you show your points. Okay, so that's a circle, shaded in circle. Where this one, it's an open circle, because it doesn't include that point. And we'll show you what that means in just a second here. Closed circle for anything that's equal to. For anything that's just greater than or less than, it's open circle. And I'm going to show you 2 examples here in just a second. Just want to let you get that down. And then we're going to do a bunch of practice. I'm feeling pretty generous, so I don't think I'll give you homework tonight. All right, let me move this up a little bit. Hold on, I'll move it back down a little bit. Hold on. Okay. We got that? Okay, as you're finishing up, I'm going to put two examples up here that we're going to solve, and then we have to graph our solutions. Okay, I'm going to move this down now. Okay, here's one expression. There's an equation. And then here's another. So we're going to show you how we solve this. Okay, graphing an inequality is just like graphing an equation. We still solve for the variable. So just treat the inequality like an equal sign. Okay, you know how we move things across the equal sign by doing its opposite? So the same thing here. So if I want to get n by itself, what has to happen? Maria? Subtract 4 to both sides, right? When I do that, the 4's cancel out here, leave me just n. The inequality sign stays the same. And what's 7 minus 4? 3. So our answer is n is less than 3. Now again, there's lots of numbers that are smaller than 3, right? So what we're going to do is, we're going to draw a number line. All right, here's 3. And I'm just going to draw a few numbers to the right and a few numbers to the left. Okay, there's my number line. So the answer was 3, right? And when we have just greater than or less than, we use the open circle, right? So I'm going to go to 3, and I'm going to draw an open circle. That means we can't include the point 3, right? Because if I were to plug a 3 in for n, is 3 less than 3? No, it's equal to. Now, every point that's smaller than 3 is an impossible answer, right? Okay. So which direction should I go to make that right? Left, right? Now, lots of teachers obviously teach us a different way, can do this. Some teachers do this, where they can just kind of shade the number line, like this. Or some people draw like a little arrow going that way, however you want to do it. But basically what this little number line graph means is all the answers less than 3 make this inequality right here, this, true. That's solution true. Okay? If you shade the wrong way, obviously that's not correct, right? 4 is not less than 3, right? Not too bad on that one? All right. So let's look at the second one. The second one's got an equal to, right? It's the only difference. So again, we have to get x by itself. So Sal, how am I going to get x by itself? No, how am I going to get x by itself? What do I have to do to the 5? No. I got to subtract 5 to both sides. I got to get it over here. All right. So I'm left with x because these 5's go away. I leave the inequality sign the same. And what is 2 minus 5, Zane? Negative 3. So there's our solution, right? So again, because there's a lot of numbers, we got to show it on a number line. So draw your number line. Just put a few numbers up here. Okay, now, what kind of circle? Closed, because it's equal to, right? Which means it has to include negative 3, right? Because think about what it says here. Is negative 3 greater than or equal to? It's equal to, right? There's two possibilities because we use the word or. Okay, so that's why we have to do a closed circle. And now we have to go, it's greater than, right? So which way on the number line are the numbers get bigger? To the right. So again, you can either draw your arrow, or if you like to shade, if you like to color, you can shade as well. Either way is fine. Not too bad? Okay, here's what we're gonna do. I just want to make sure everyone gets this done here. Because you're gonna help. This is gonna help you do a couple. I'm gonna give you a couple examples to kind of play around with in just a second. I just see a few pencils going. I want to make sure you guys get it down. I'll tell you what here. We're gonna just pause the video while you guys finish writing this down real quick. All right. So now that we got that down, I'm gonna give you two examples that I want you with your table mates to try and see how you do. So this is. And don't forget, too, after you solve it, graph it on a number line. Okay, we're going to give you about 3 minutes to work on these two questions with your teams at your table. So we're going to pause the video and let you guys go ahead and solve these. All right, so let's see how you did. Folks, conversation's off. Hey, I didn't stutter. Conversation's off. All right, so to solve for b, to get b by itself, I got to move the 3.5 over here, which means I have to do what? Subtract. So when I subtract 3.5 to both sides, I get negative 8.5 is greater than b. So when you go to graph this, negative 8.5. So what I just did is I just did whole numbers on the graph. If you did halves, that's fine. But let me just show you. Let me just put a few numbers up here. So I know that negative 8.5 is halfway between negative 9 and negative 8, right? What kind of circle is it? Open. So I'm going to put an open circle halfway. And now, which direction am I going? Left or right, Robert? Left, because this is bigger than any other number, right? So we have to go that way. Very good. How many people got that one? Everybody. Awesome. All right. So in the second one, you got t minus 5 equals 12. So to get t by itself, what do I have to do, Peyton? Add 5 to both sides. So when I add 5 to both sides, I have to do the opposite to get rid of it. T is greater than or equal to 17. So if I have 17 right there in the middle, just make sure you got some numbers on each side. Okay. At 17, what kind of circle, Sophia? Closed, because it's equal to. And then t is greater than or equal to 17. Which direction am I going, right or left? Remember, any number is greater than or equal to 17. So think of numbers bigger than 17. 18, 19. So we have to go to the right. Bigger than. And again, if you're not sure, plug in a number. Plug in any one of these numbers. If you plug 16 in for t, is 16 greater than or equal to t? No, so it's not this side. You know it's the other side. That can help you. All right, you ready for two more? Well, some people said no. Well, ready or not, here it comes. All right, now, remember, it's the same thing as solving an equation. So there's one. We did these in solving equations. It was just with an equal sign. Don't let the inequality. Let's try those two. I'll tell you what, we'll do this one together. So if I have a fraction, how can I get x by itself if 2 is in the denominator? Who remembers how to do this when we had a fraction? We showed you this in solving equations. Joey. Right, you multiply by 2, because this is saying x is divided by 2. So what's the opposite of division? Just like when we have, if it was 2x, that's multiplication, you would divide, right? So multiply both sides by 2. When I multiply both sides by 2, this becomes 1, because it's 2x over 2, which is 1. So I'm left with x is greater than or equal to negative 8. So if I put negative 8 here, here's negative 9, negative 10, negative 11, negative 7, negative 6. So what kind of circle at negative 8? closed because it's equal to. And now, negative 8 is less than or equal to x, any number. It's smaller than any other number. So which direction am I going, right or left? I'm going to the right because these numbers are supposed to be bigger. And remember, the number line for numbers to get bigger is always to the right. All right, so there's that one. I want you to do the other one as a team. We're going to pause real quick, give you a couple minutes to do the 5b is greater than 40 problem. Okay? So what did you come up with for the one on the left? What'd you get, Robert? All right, so we divide by 5. So when I do that, b is greater than, what's 40 divided by 5? 8. So, 8, 9, 10. What kind of circle at 8? Open because it's not equal to. And then which direction am I going?
To the right.
Any number is greater than 8. Bigger, going to the right. All right, you ready for your last two?
Yeah.
Here, so let's number these. So this was, this was number 4. This was number 3. Up top was 1 and 2. All right. So here, let's just separate them. All right, we're going to extend the page here. Hold on, I'll go back up just so you can get it. Okay, here are your last two problems.
Oh, I clicked on the 113.
Can I move it up now?
Yeah.
No, this part.
Yeah.
So you can see this part better. Okay. And then again, don't forget your number lines down here. Okay, we're going to pause again and let you work on these last two. I'll use green. So, we had to move the 6 over first, right? Yep, by adding it. So, you get 11z is less than 44. And when you divide by 11, z is less than 4. So, if I make my line graph, okay, so our points at 4, open or close circle? Open, because there's no equal. And then which direction am I shading? Any number is less than 4. To the left. All the numbers are smaller then. All right, let's do our last one. So, I got a 1 here, right? I get rid of the 1. How do I get rid of the 1? Subtract it. Negative 12 is greater than or equal to 3n. So again, n by itself, I got to divide by 3. So I get negative 4 is greater than or equal to n. Let's get that out of the way. All right, so here's negative 4. Here's negative 5. Here's negative 6. Okay, so here's at negative 4. Open or closed? Closed. And now which direction? Negative 4 is greater than or equal to any other number. It's to the left. It's like saying, you read it, if you go from the variable, you're saying less than, so it's this way. How many people got 5 and 6? Awesome. All right, so we will work some more. We will practice this next week.